So today we're going to talk about how to solve linear quadratic systems. So before we've talked about linear systems, so two lines. So today we're going to talk about what happens when you have a line and a parabola. So we're going to talk about how to graph and then how to do it by substitution. So by graphing, you have y goes to negative 2x plus 3, so that's a line. Y equals x squared minus 6x plus 3, so that's your parabola. So the line is fine, so let's work on the parabola first. So standard form, find the vertex. X equals negative b, so 6 over 2 times 1, which gives us 3. Sub back in, 3 squared minus 6 times 3 plus 3, which gives us negative 6. So our vertex is 3, negative 6, and our y-intercept is this c right here, so 0, 3, okay? So then you can graph whichever one you want first. So let's graph the line first. So up 3, and then down 2 over 1 for the slope. So there's our line, okay? And then for our parabola, vertex at 3, negative 6, y-intercept at 3, which is there. So then you go 3 over to the vertex and then 3 over to the right side to get that third point, okay? So then nice and carefully, there you go, okay? If it doesn't intersect the line, you would just extend the line so that it does intersect it, okay? So there are our 2 points. So this one's nice and easy. That one's just your y-intercept, 0, 3. And like before, when we graphed systems of linear equations, we just estimate, right? So this other point, maybe 4, negative 4. So our 2 solutions are 0, 3, that's for sure. And then somewhere around 4, negative 4. Okay, so remember, it depends on what your graph looks like. If you get 4, negative 5, or 4, negative 5.5, somewhere around there, that's fine, okay? But you should get 2 points in this case. Okay, so let's look at the next one. So here, for the line, if you wanted to solve for slope-intercept form, just move this y over and move the negative 4 over. So you get y equals 1/3 x plus 4, okay? Same thing for the parabola. You want to find the vertex, so x equals negative 4 over 2 times 2, which gives us negative 1. And then when you plug it in, y squared equals 2 times negative 1 squared plus 4 times negative 1 minus 4. Just make sure when you do it, if you do it by calculator, you do put parentheses around your negative 1 before you square it, okay? So then you should get y equals negative 6. So then your vertex is negative 1, negative 6. And your y-intercept is 0, negative 4, okay? So then when we graph this, there we go. So graph the line, go up 4 for the y-intercept, and then up 1 over 3 for the slope. So make your line nice and long. For the parabola, -1, -6. Y-intercept at -4. So then 1 over to the vertex and then 1 over to get the third point. So kind of come up here so it intersects the line. All the way up here, there you go. Okay, so then your 2 points where they intersect are your solutions, don't forget that, okay? So let's say -3, 3-ish, and then maybe 1.5, 5-ish. So there are 2 solutions, -3, 3, and 1.5, 5, okay? I'd like you to write out the solutions separately and just kind of square them or circle them, okay? And there you go, okay? So change the line to slope intercept form if you need be. Do a vertex y-intercept for the parabola, and then see where the 2 intersect, okay? If they intersect. Okay, good? Okay. So let's look at the other method. So that was method 1, solving by graphing. So let's look at substitution. And this should be a little bit easier, okay? We don't do that last method, the linear combination or elimination, just because we don't really need to, because it's easier if you graph it or you do it by substitution, okay? So y equals, so then we just take this and put it into here. Okay, so remember how substitution works. So then we get -x, substitute that in, equals x squared minus 4x plus 2. Anytime you have an x squared, you want to set equal to 0, okay? So 0 equals x squared, add the -x minus 3x plus 2, and then see if it factors. And in this case, it does. So then you get x minus 2, x minus 1. If you do that big X equals 0. So then x minus 2 equals 0, x equals 2, add 2, add 2. X minus 1 equals 0, add 1, x equals 1. Okay. So then you say, well, are we done? You say no, because that's only the x and we have to find y. So we sub back in. And it doesn't matter if you sub back into here or if you sub back into here, okay? But might as well sub into the first one just because it's so much easier, right? So x equals 2. So then y equals -x. So for x equals 2, y equals -2. So then you get 2 and -2. For x equals 1, y still equals -x, so y equals -1. So then you get 1, -1. So then these 2 are your 2 points. If you graph them, you would intersect there. Okay? Okay, let's look at number 4. Okay. So in this case, you can either solve the first one for y, or just put this whole entire parabola in here. Okay, either way. Just be careful. You want to, so x minus, put that in parentheses when you sub in, equals 4. Whoops, 4. Okay. Just so you distribute that negative. So x minus x squared plus 6x minus 6 equals 4. Negative x squared plus 7x minus 6 equals 4. Okay. So what you want to do is actually push everything over to the right side so that x squared is positive. Okay. So x squared minus 7x plus 10 equals 0. Okay. Or you could push the 4 over this way and just change all the signs, either way. But that x squared term should be positive, just to make your lives easier, okay? So if you do the big X, you get x minus 2, x minus 5 equals 0. So then x equals 2, x equals 5. Okay, so you can do it that way, okay? So then plug it back in. We can do 2 minus y equals 4. So negative y equals 2. So y equals negative 2. So then you get 2, negative 2. X equals 5. 5 minus y equals 4. Negative y equals negative 1. So y equals 1. So then you get 5 comma 1. Okay. So make sure once you find x, you do plug back in to find y. Because remember, systems, you want to find the points that the two graphs would intersect at. If you can't factor, so if you happen to get a quadratic at this step that can't factor, then you would just use the quadratic formula or completing a square. But usually for this stuff, hopefully it factors. Okay, so that's substitution. So let's go ahead and look at the back for a couple of word problems. Okay, so then number 5 says the equations y equals that and y equals that model the daily sales of two types of computers. X is the number of days, and so y is the number of computers they sell. Okay, on what day was the same number of each type of computer sold? So for these types of problems where it says same, you just set them equal to each other. Okay. Sorry, guys. Excuse me. So then you get negative x squared plus 120x plus 15 equals 24x plus 15. So then you can subtract 15, subtract 15. So then the 15s go away. Okay. And then you subtract that 24x, or you can push everything over to the right side to get everything positive, either way, okay? So if you push everything over to the right side, so plus x squared minus 120x, you get x squared minus 96x equals 0, okay? Again, if you wanted to push the 24 over to that side, you can. You would just have to change the signs. Okay. So in order to factor, you just do GCF. Remember, we check for that all the time. So x times x minus 96 equals 0. Here, we say x equals 0 or x equals 96. Okay. X equals 0 doesn't make sense. That's just 0 days. So we don't want that. So we take 96 days. They will sell the same number of computer. Okay. Okay, let's look at the second one, number 6. So same thing. So we have equations for pool A, pool B, and it says On what day was the attendance the same? Okay, so we set them equal to each other. So 28x plus 4 equals negative x squared plus 39x plus 64. Okay, push everything over to the left side. You get x squared minus 11x minus 60 equals 0. This factors nicely for us if you do the big X. X minus 15, x plus 4 equals 0. So then x equals 15 and x equals negative 4. Okay. The negative 4 doesn't make sense because it would be negative 4 days. So we take the 15 days, the attendance is the same. Okay, so nice and easy there. And then part B says, well, what was the attendance on that day? Well, you would take 15 and sub in for x into either equation, okay? Might as well take the easier one. Y equals 28 times 15 plus 4. So now y equals 424 people were at each pool, okay? You can, of course, take the equation for pool B, and it comes out to the same number because it has to. So might as well take the easier one. Okay, what do you think? Good? Then that's it.